Hi engineers, in this lecture we are going to see about the diffraction. Then when come to the syllabus, in this part we have daily life examples, difference between interference and diffraction, then difference between Fresnel and Fraunhofer diffraction, single slit, plane diffraction, grating and resolving power. This is the total syllabus of diffraction, and as a first part we will discuss about the difference between Fresnel and Fraunhofer diffraction. So diffraction is nothing but a bending of light waves around the corners of an obstacle, right, as shown in the figure. So whenever the light rays pass through this slit, they will get diffracted and spread over all the directions. Then diffraction effects depends on size of the obstacle. It may be aperture. In some cases, we can get the diffraction based on a sharp edges also. Say if this is a sharp edge and light ray is coming here, then it will get and diffracted here in many directions. So diffraction of the light takes place if the size of obstacle is comparable to the wavelength of the light. Then these are the some of the daily life applications in diffraction. Then when come to the difference between interference and diffraction, we can see the pattern here carefully, that from the figures we can understand that in the interference the intensity is all bright fringes have the equal intensity, whereas in a diffraction it is changing. So from this figure we can understand these points. So whenever interference is taking place, this is due to superposition of two different wavefronts originating from two coherent sources. So for interference we required two coherent sources, whereas for diffraction it is from the superposition of secondary wavelets but originating from the different parts of the same wave. Then interference bands are equal width, whereas diffraction bands decrease in their width as their order increases. Then when come to the interference, the bright fringes have same intensity, whereas in diffraction it is changing. And when come to the intensity of dark fringes, for interference it is 0, whereas in diffraction it is not the 0, so it may vary. Now when come to the types of diffraction, we have basically two types of the diffraction. One is Fresnel diffraction, another one is a Fraunhofer diffraction. From this figure we can understand the differences, where in Fresnel diffraction we have a source, slit, screen which are at a finite distance, whereas in a Fraunhofer diffraction source is at infinity and slit and screen are near. Source will be at infinity. And in second difference is, in a Fresnel diffraction we don't need any lens, but in Fraunhofer diffraction we require a lens. And when come to the source, in a Fresnel diffraction it is a point or spherical source, spherical wavefront it will form, whereas in Fraunhofer diffraction whatever may be the source, but the wavefront should be a plane wavefront. And when come to the analysis, Fraunhofer diffraction is a simpler compared to Fresnel diffraction. And finally, the central spot of Fraunhofer diffraction is a bright, and Fresnel diffraction is, it may be bright or dark based on the specified conditions. Then these are the table whatever we discussed previously. Now these are the different types of the patterns we will get for different type of the slits. Next one is Fraunhofer diffraction at single slit. This is the one of the important concepts. So this is the lab arrangement. In the lab what we will do is we will take a laser and we will assume a plane wave front is approaching the slit. Then once the light pass through slit, it will get diffract and form diffraction pattern, or that's a light intensity pattern. So in the coming video we will see about the Fraunhofer diffraction at single slit and we will discuss that concept. Have a great day.